Okay, let's start today new lesson. Write down topic integration. Topic integration. Integration. Okay, see this and all. See this and all. In mathematics, we have especially pure mathematics four different sections. We have four different sections. Okay, first one trigonometry, algebra, then coordinate geometry, and calculus. Four different things to discuss. Then geometry, trigonometry, both related with graph and geometrical relations. Geometrical relations. Algebra, pure simplifications. Pure simplifications. Okay. Then here integration. Integration in calculus we have limits, differentiation, and integration. Limits, differentiation, and integration. Then we know here when you consider a function like this, consider x-axis, consider y-axis. So its variation we analyze using differentiation. Its variation we analyze using differentiation. So by differentiation, you take this general point x comma y, then gradient of this tangent we can obtain. By differentiation, gradient of this tangent we obtain. We call dy by dx equal tan theta. Tan theta, gradient of the tangent at P. Therefore, by differentiation, we analyze gradient. Then increment rate we can analyze, and concavity we can analyze, and especially critical points we can analyze. Then rate of change, then increment rate, those things we can analyze. Therefore, physical quantities, when you consider time, distance, or displacement, when you consider this graph, there can be some graph like this. Therefore, if you consider some point here, then tangent represent displacement variation rate. That means velocity, no? Instantaneous velocity. Then by differentiation, we can obtain instantaneous velocity. Then likewise, we can analyze different combinations, different properties of physical quantities using differentiation. Then y equal fx is a function. Then differentiating, we get f dash x. Then reverse process of that we call integration. Then by derivative, finding function we call integration. Reverse process. Here differentiation, finding gradient is reverse process. Finding function we call gradient. Sorry, integration. That is fundamental concept of integration. Finding the function. By using this integration, see this one, you consider here x-axis, y-axis. By using this integration, when you consider this type of graph, and if you consider this type of graph, here linear one, here not linear, no? So if you need this bounded area, then general geometry we can apply. This is trapezium. Then to find this area, general geometry we can apply. It is trapezium. Now for this one, bounded area, we can't do such a way. If you need bounded area, we can't get such thing. So then to find this area, we split this into small sections, very small sections. Then if you consider the small section, if you zoom it, then now it is something like this. That was a curve. It has some curve here. Okay. But if you split that into another small parts, then finally you can say it like a trapezium. That is like a trapezium. So if you consider this small portion, that is rectangular part, but actual figure like trapezium, small tiny part. Huh? Then if you consider this part, that is rectangular shape. So if you find this rectangular shape area, that approximately equal to trapezium area, that approximately equal to this part area. That is the concept. Therefore, by integration, we can find this area. Then we can find volume. Okay, we can find center of gravities. We can find moment of inertia. Those are applications of integration. එවනට අපිට කොහොමද integration වල application ලොකුවට analyze කරන්න නැහැ syllabus එකේ. තියෙන්නේ differentiation proof ටික විතරයි. Okay, that is the thing. So anyhow, you identify here differentiation, then reverse process we call integration. Reverse process we call integration. That is the thing. Okay. Okay, just write down. Just write down. Let a function y equal fx. Let a function y equal fx. Let a function y equal fx. Its variation can be analyzed geometrically by the graph. By the graph. By differentiation, the gradient of the tangent drawn to the curve, at a certain point is given. Then the reverse process of finding function, not finding function, the reverse process is called integration. It's called integration. Within bracket, finding function. Within bracket, finding function. Finding function. Okay. Put a stomach and write down. The above definition is the fundamental concept of integration. Fundamental concept of integration. By using integration, area, volume, moment of inertia, center of gravity, put some dots, can be obtained. Can be obtained. Okay. Now say this one. If you consider x square, its derivative 2x. No? Then integral we call I. Integral we call x part. We call integration. Then sin x, derivative we say cos x. Then cos x integral we say sin x. Here differentiation, integration. That is fundamental thing. So if you consider, it goes like that. A function, general function fx, its derivative we define f dash x. Then reverse process we call integration. Integration. Here differentiation, process, differentiation is process, integration. So here this is equal derivative, this is equal integral. Integral. Integral of f dash x. Here derivative of fx. Okay. This is equal derivative f dash x, derivative of fx. And this is we call usually function or integral of f dash x. F dash x. Okay. This process we call differentiation. Differentiation. And I we call integration. Okay. Write it. Write it. Okay. That is fundamental definition. Okay. This is fundamental definition of integration. Okay. Now you see this x bar derivative, we say 2x. Then integral will be 2x, integral will be x bar. Then x bar plus 1 derivative 2x. Then 2x integral will be x bar plus 1. Then x bar plus 2 derivative 2x integral will be x bar plus 2. Then x bar minus 1 derivative 2x integral will be x square minus 1. දැන් පොඩි අවුලක් තියෙනවා. We have same results, then but when we integrate we have many solutions, many results, no? Many results. Therefore, here differentiation integration process result is not definite. Okay, not definite value. This is called indefinite integral. Therefore, we have integration two types. One is called indefinite integral, the other one is called definite integral. This is indefinite because here 2x integral x square plus 2, 2x integral x square minus 1. So likewise, x squared plus c derivative for any constant result 2x integral x square plus c. Okay, write this one as well. Write all. Okay, which star mark write down. Due to the above result, integrals can be different. Integrals can be different for same function 2x. Same function 2x. Therefore, this integration is said to be indefinite integrals. These integrals are said to be indefinite integrals. Indefinite integrals. Indefinite integrals. Okay, now see this. Take function fx, you add a constant c, then corresponding derivative f dash x, then integral will be fx plus c. This is indefinite integral. Notations, dfx plus c divided by dx we call differentiation, that is f dash x. Here differentiation. Differentiation. Then notation f dash x dx. Here this is integration sign, integral sign. Integral f dash x dx. The result is fx plus c. Fx plus c. Here integration. Integration of fx with respect to x. Here this notation represents integration of fx with respect to x. Then c can be any constant. C can be 1, 2, 3, 4, 5, 6, minus 1, minus 2, 0, all are possible. Because of that, c we say arbitrary constant. Any constant that we call arbitrary constant. That's how we denote integral. Here integral sign f dash x dx equal fx plus c. C we call arbitrary constant. Write it. Write all. Okay, these are just notations. These are just notations. Integral f dash x dx equal fx c. If you can identify this one as derivative, then corresponding function will be the integral with constant. No? Okay. Now we say fx derivative f dash x derivative f dash x. Similarly, fx integral we call capital Fx. These are just notations. Then f dash x integral we say function fx. But fx integral we say capital Fx. Again, f dash x අපි දන්නවනම් කෙලින්ම fx කියලා ලියුවයි. But if we don't know that as a derivative, then fx integral you write fx and plus constant c. Then here this one we denote by integral fx dx equal capital Fx plus c. Then usually fx dx we denote by capital Fx plus c. C arbitrary constant. Then integral f dash x dx we say fx plus c. Okay, similar thing. Okay, put that note as well. Okay, remember that notation. This is we call indefinite integral. Okay. Now according to my definition, ex derivative ex, then ex integral ex. Sin x derivative cos x, then cos x integral sin x. Okay, cos x derivative minus sin x integral cos x. Tan derivative sec x integral tan x. Then we have 16 different functions and their derivatives. Previously we have analyzed. Then using that table, we can get integral table. Okay, write down integrals of special functions. Integrals of special functions. Integrals of special functions. Okay, just write. As according to the above definition, as according to the above definition, as according to the above definition, integrals of special functions are given below. Integrals of special functions are given below. Okay, now say this. So in differentiation, we have 16 different functions. Y equal constant, y equal x to the power n, ex, ln x, sin cos tan sec cosec cot, inverse trigonometric 6 functions. Likewise, there are 16 different functions. But for integration, we don't have all directly. Okay. Consider y integral x to the power n. Here first one. We say this one x to the power n plus 1 over n plus 1 plus c. Okay. Here n not equal minus 1. N not equal minus 1. This is first one. So if you differentiate right side, you get inside function. If you differentiate right side, you get inside function. X to the power n plus 1 over n plus 1 derivative. N plus 1 x to the power n over n plus 1. Cancel n plus 1, we get x to the power n. No? X to the power n. Then just remember x to the power n integral x to the power n plus 1 over n plus 1 plus c. C arbitrary constant. Then 1 over x dx. ln x derivative 1 over x. ln x derivative 1 over x. Then 1 over x integral ln x. Then 1 over x integral we say ln x. ln means log function. Then here x can be positive or negative, but for log function we need to put positive values. Then definitely we need to put modulus. This is ln x plus c. Then ex integral, we know ex derivative ex, then ex integral ex. Ex plus c. Sin x, cos derivative minus sin, then sin integral minus cos x plus c. If you differentiate this, minus cos x derivative sin x. Then cos x dx, sin derivative cos integral sin x plus c. Then sec x dx, tan derivative sec then sec integral tan cosec quad, cot derivative minus cosec quad, then cosec quad integral minus cot. දැන් කලින් වගේ differentiation වගේ ලස්සනට functions ඔක්කොම යන්නේ නැහැ. sin cos tan sec cosec cot කියලා ඔහොම ඔක්කොම යන්නේ නැහැ. Okay? Because we don't have result for you can sec කියලා result එක ගන්න no result. Therefore sec tan derivative sec then sec integral tan. Reverse එක අර වගේ ලස්සනට process වෙන්නේ නැහැ. Then sec x tan x, sec derivative sec x tan x, then sec x tan x integral sec. Cosec x, cot x, cosec x derivative minus cosec cot, then minus cosec cot integral minus cosec x plus c. Integral dx over 1 plus x squared, tan inverse derivative 1 over 1 plus x squared, then 1 over 1 plus x squared integral tan inverse x plus c. Or here possible minus cot inverse x plus c also possible. Because minus 1 over 1 plus x squared derivative cot inverse. Cot inverse. Then we have two results. Dx over 1 minus x square root. Sin inverse derivative 1 over 1 minus x square root. Then 1 over 1 minus x square root integral sin inverse x. Or we have another result minus cos inverse x plus c. Last one dx over x times x square minus 1 root. We say, we have modulus here. We say sec inverse x. Or minus cosec inverse x plus c. Here it is. Now we have 12 different integers. You need to remember you can take all directly. Okay? You can take all directly. Okay. Write them. Write them. n not equal minus 1. Here n equal minus 1 case. 1 over x to the power 1 over x mean 1 over x mean x to the power minus 1. Then we have two different cases. Okay. Now these are direct integrals. Now we know only 12 integrals. We know only 12 integrals. Okay. But functions can be many. There can be many functions. No? So if you consider sine function, sine x can arrange different ways. Then 2 sine x. Then sine 2x. Sine 2x minus 5 divided by 4. Likewise, there are many functions. But we know only integral of sine x, not 2 sine x, not sine 2x, not sine 2x plus angle. We know only sine x integral, not the others. Huh? Not the others. And also, we can have composite functions. We have composite functions like sine x plus cos x. Sin x plus cos x. We know only integral of sine. We know only integral of cos. Not for addition, not for subtraction, not for multiplication, not for division. Then we don't know how to integrate function of a function. Then composite functions. Then to integrate those type of functions, we have rules and theorems. Okay, we have rules and theorem, and we have special simplifications. හරිද? මේ 12ට එහා යනකොට අපි මේ වගේ දේවල් apply කරගන්නවා. These 12 you can apply directly. Okay, write down. All the above functions can be connected together by algebraic operations. By algebraic operations. By algebraic operations. And also they can be composite like a function of a function, like a function of a function. And also there can be different functions like exponential functions, logarithmic functions, inverse trigonometric functions. Put some dots. Put some dots, okay? Then to integrate those type functions, to integrate those type functions, we use first one, rules and theorems on integration. First one, rules and theorems on integration. Second one, use special simplification techniques. Use special simplification techniques. Third one, special substitution method. Special substitution method. Special substitution methods. Fourth, integration by parts. Okay. Now you know integration by parts. That's it. Okay. Now you know usually integration means reverse process of differentiation. Therefore, especially we call that is find-in function. So if we know derivative, then we can say its function is integral. Okay. Then these are 12 different integrals. 12 different integrals. You can apply them. Okay. Now let's see special integrals, further special integrals. Okay. Now before that, let's take this relation. Okay, now you do with me. Take this relation. See examples. X to the power 4 integral. You directly write x to the power 4 plus 1 or 4 plus 1 plus c. That is x to the power 5 or 5 plus c. That's it. Do with me. Question number 2. X to the power 3 dx. X to the power 4 or 4 plus c. No need two steps. You can write at once. 3 integral x to the power minus 2 dx, x to the power minus 2 plus 1 over minus 2 plus 1, x to the power minus 1 over minus 1 plus c. Don't forget to put arbitrary constant. For x to the power 1/3 integral, you can do same, x to the power 1/3 plus 1 over 1/3 plus 1 plus c. 5 x to the power square root 2, you do same, x to the power root 2 plus 1 over root 2 plus 1 plus c. 6 1 over x to the power 4 dx, x to the power 5, x to the power minus 5 dx, x to the power minus 4 over minus 4 plus c. Likewise, you can directly write. So by this, you can take many polynomial types. Right all. Okay. Now with that, this is special. If you have just dx, that means x to the power 0 dx, x to the power 0 dx. Then x to the power 0 like x to the power n. Then x to the power 0 plus 1 over 0 plus 1 plus c. That is x plus c. Seventh one. Do that. Seventh one. Just dx, it is x plus c. Okay. Okay, now say this. Not only for variable x, but also for any variable, this integration applicable. Okay. So x to the power 4 dx, we say x to the power 5 over 5 plus c. No? Likewise, t to the power 2 dt, here we need to integrate by t. No? Then t cube over 3 plus c. Then z to the power minus 3 dz, integrate with respect to z. Z to the power minus 2 over minus 2, no? X to the power n plus 1 over n plus 1 plus c. Okay. Then y to the power half dy, do same. Y to the power half plus 1, 3 over 2, divide by half plus 1, 3 over 2 plus c. Okay. Then integration applicable with any variable. Integration applicable with any variable. Put a stomach and write down. The integration is applicable with an any variable, with an any variable. Okay, write these examples. Okay. Now you put another subtopic, roles on integration. Roles on integration. Okay, now here we have special two rules. So for differentiation, we know constant time function is constant time derivative. Addition of two functions equal to addition of derivative. No? Then likewise integration also same. But for multiplication and division, differentiation different. No? We have product rule and quotient rule. Integration, we don't have any rule like that. Okay, see this. Constant time function integral, here rule 1. Rule number 1, you can take constant outside, only constant. Huh? You can't take any variable outside. You can take only constants. Still, I haven't integrated. Huh? Then no need to put C. No? I took only K outside. No? Okay. Then rule number 2, if you have sum of two functions to integrate, you can split it. Fx dx gx dx. Likewise, you can separate it. So for minus, put minus. Likewise, you can separate it. We have two rules. Then if you see 2x to the power 3 integral now you can do. You take 2 outside, x to the power 3 dx, then integrate. X to the power 4 over 4 plus c, no? Then x to the power 4 over 2 plus c. Here first apply rule, then integrate, then simplify. Then if you have sin x minus half sin x integral dx, you apply rule, take minus half outside, then sin x dx. Cos derivative sin integral minus, then minus cos x. Put constant c. Then 1 over 2 cos x plus c. That's how we apply first rule. Then example 3. If you have x to the power 4 plus x to the power 2 dx, you can separate x to the power 4 dx plus x to the power 2 dx. Don't write integral without dx. Dx must. Then x to the power 4, x to the power 5 divided by 5 plus c 1, x to the power 3 divided by 3 plus c 2. There can be two arbitrary constants for each integrals. Then by adding these two, you put another new arbitrary constant, x to the power 5 over 5, x to the power 3 over 3 plus c. Just write c. No need to put two separate arbitrary constant. You can write at once at this stage. හරිද? දෙකක් ලිව්වේ නැතුණාට කමන්නේ. මෙතෙන් දාම just c එකෙන් දාගත්තට කමන්නේ. Okay? Then that's how we integrate. Rules on integration. Write these two rules, then write examples. Now you can integrate combination, addition and addition of functions. No? Okay, now let's do further examples. Do with me. Do with me. 2 sin x plus cos x dx. Do with me. 2 sin x dx plus cos x dx minus cos x sin x, you put constant, arbitrary constant at once, minus 2 cos x plus sin x. Okay, now need to put c1 plus c2, you can just write it. X to the power 4 plus 3x square minus x plus 1 over x. Here there's division. We don't know how to integrate division. But you can separate denominator. X to the power 3, 3x minus 1, 1 over x dx. Now you know rule, no? Then no need to separate it like this. No need to separate it. Do at once. X cube, x to the power 4 over 4, 3x squared over 2, 1 integral x, 1 over x integral ln, put modulus, plus c. Likewise, you can do at once. Okay. In your mind, you apply rules and do integration. Okay. Continue. You continue these integrals. Continue these integrals. You can't separately put integrals for product. You can expand within integral, then integrate. Okay, do soon. ඔයාලා මේ ඉන්ටිග්‍රේෂන් කරද්දී ඉන්ටිග්‍රේට් කරන්න දන්නේ නැත්නම් මොනවද කියලා දැනගෙන ඉන්නත් ඕනේ. මම කියන්නේ ක්ලියර්ද? ඒ කියන්නේ දැනට දන්නේ නැත්නම් මොනවද කියන එක දැනගෙන ඉන්න ඕනේ. මම ඔයාලට tan ඉන්ටිග්‍රේට් කරන්න කියලා දුන්නේ නැහැ. cot දුන්නේ නැහැ. sec cosec දුන්නේ නැහැ. inverse functions එකක්වත් දුන්නේ නැහැ. division එකක් තියෙද්දි කොහොමද දුන්නේ නැහැ. product එකක් තියෙද්දි කොහොමද කියලා දුන්නේ නැහැ නේ. එහෙනම් අපි දන්න type එකට convert කරගෙන තමයි integration එකට යන්න ඕනේ. ඒකයි මම කිව්වේ මෙතන product එකක් තියෙද්දි බෑ. ඇතුළ expand කරලා separate කරන්න. Division we don't know. Separate denominator integrate. Whole thing to the power thing we don't know. Expand and do integration. Okay, take little time. Okay. Now here x to the power 5, x to the power 4, 3x squared minus x plus 3x plus 2x minus 1 dx. හරි නේද? Okay na? X to the power 4, x to the power 5, x to the power 4, 3x squared, 3x minus x, 2x minus 1. Okay, now you can integrate. X to the power 6 over 6, x to the power 5 over 5, 3x cubed over 3, 2x squared over 2 minus x plus c. Separate here denominator. Integral 1 minus 2 over x. Then 1 x minus 2 take outside. You can separate now. Dx dx of x. Then x 1 over x ln x modulus plus c. Then here x squared plus 2x plus 2 plus 1 over x squared dx. X cubed over 3 plus 2x, x to the power minus 2, x to the power minus 1 or minus 1 plus c. Then 2x cubed, 3 times 2x squared, 3 times 2x minus 1 dx. Simplify a little. 8x cubed dx, 12x squared dx, 6x dx dx. X to the power 4 over 4, x to the power 3 over 3, x squared over 2, x plus c. Okay, here 2 e to the power x plus minus cos x plus c. Here 1/3 minus cos x for sin x plus c. Don't forget to put constant after constant. That's how we do. Okay, now you continue further. Continue further. Continue. Do them. X to the power n plus 1 over n plus 1, x to the power minus n plus 1 over minus n plus 1 plus c. Here this must be, here this given n not equal plus or minus 1 දෙන්නම දෙන්න මේ කියන්නේ නෑ කියන කියන්න ඕනේ මුලින්ම. Then here separate denominator x power over root x, x 2 minus half 3 over 2, 1 minus half for x to the power half, x to the power minus half dx. Separate denominator and simplify. Then 3 x to the power 3 over 2 plus 1, 3 over 2 plus 1, x to the power half plus 1 over half plus 1, x to the power minus half plus 1 over minus half plus 1 plus c. X to the power minus 2 over 3 plus 1, minus 2 over 3 plus 1, x power over 2 plus c. X cube, x to the power 4 dx. X to the power 4 over 4, x to the power 5 over 5, x plus c. 1 over 2 take outside, x to the power minus 3 over 2 plus 1, minus 3 over 2 plus 1 plus c. Then expand this, take 1 over 2 outside, expand, then integrate. 1 over 2 x, 2x cube over 3 x to the power 5 over 5 plus c. මේ c කියන එක මේ බ්‍රැකට් එක ඇතුළට ඕනේ නැහැ. c කියන එක වෙනම ඇඩ් කරලා තියන්න. හරිද? බ්‍රැකට් එක ඇතුළේම ඕනේ නැහැ. මේක එළිය තියෙන ඉඳලා plus c එක කොහෙ තිබුණත් කමන්නේ arbitrary anything okay. Okay, now you further continue. Okay, continue. Take little time. For these two need trigonometry simplification. Here with square root you don't know how to integrate. If you can remove the square root, then you can integrate. But don't square. Don't square. Take time. Okay, let's see. 1 minus x squared to the power 2 of x dx. 1 minus 2x squared x to the power 4 over x dx. 1 over x, 2x, x cube dx. ln modulus x, 2x squared over 2, x to the power 4 over 4 plus c. X squared over root x squared plus 8x plus 2 over root x. Then here 2 minus half, x to the power 3 over 2, 1 minus half, x to the power half, x to the power minus half dx integral. Separate denominator and simplify. I did that once. X to the power 3 over 2 plus 1 over 3 over 2 plus 1. X to the power half plus 1 over half plus 1. X to the power minus half plus 1 minus half plus 1 plus c. Then 1 plus sine 2x. You better to put star mark here. Okay, this simplification special, that is on trigonometry. Then 1 right sine squared x plus cos squared x. Sine 2x we know, 2 sine x cos x, whole thing root. Next line, here perfect square. Sin x plus cos x to the power 2. Then it's square root, no? That is sin x plus cos x. Now you can integrate. Minus cos x plus sin x plus c. So because of that square root, because of this square root, difficult to integrate. No? You can't do, within square root you can't do integration. No? You can't do. Definitely you need to remove square root. By trigonometry, remove that one. Then integrate. I told you, for different integrals, we need different simplification technique. Sometimes we need to use substitution. Likewise, here, special simplification. Take time. Okay. Now the last two. Tan x minus cot x dx. Tan squared x minus 2 plus cot squared x. But we don't know how to integrate tan square. We don't know how to integrate tan as well. Okay. But we know how to integrate sec quad. No? We know how to integrate sec quad. Then by trigonometry, you write tan square in terms of sec. Tan square equal sec square minus 1. Sec square x minus 1 minus 2 cot square, right? Cosec square x minus 1. Now you know these integrals. Sec square x dx minus 4 dx plus cosec square dx. You need to convert using simplification non-integral type. Then sec square integral tan x for x cosec square minus cot x plus c. That's how we integrate it. Okay, the last one, you don't know integration of division, quotient type. Then you need simplify. Cos squared x over 1 plus sin x, you do this way. So within integral, you can do simplification. Cos square 1 minus sin squared 1 plus sin x. Because of denominator, we have doubt. Now here, factorize 1 minus sin x 1 plus sin x over 1 plus sin x dx. Now cancel this factor. Now 1 minus sin x dx. 1 integral x sin integral minus cos plus c. Okay. Simplify, then integrate. Okay, we don't have exact procedure for those type. හරිද? ඔයාලට ඒ වෙලේ හිතලා තමයි කරන්න තියෙන්නේ. ඒකයි මම ඔයාලට කිව්වේ ඔයාලා දන්න ඉන්ට්‍රිගර්ස් වෙනම දැනගෙන ඉන්නත් ඕනේ. දන්නේ නැතිව මොනවද කියලා දැනගෙන ඉන්න ඕනේ. දෙකම තියෙන්න ඕනේ. Okay. Now let's move further. Let's move further. Okay, now see this. Now so far we analyzed about fundamental definition of integration. Differentiation, reverse process, integration, finding function. Then we know 12 different function integrals. 12 different function integrals. Then finally we analyze about rules on different integration. Rules. So constant time function integral, you can take constant outside. Addition of two functions, you can separate integrals. Then you can do integration. Now let's see theorems. I told you when we need to integrate some functions, still we don't know how to integrate tan, cot, cosec and sec, no? We don't know them. Then we have two theorems. Two theorems. Write down topic, theorems on integration. Theorems on integration. Theorems on integration. Okay. Now check this. Here we have two theorems, simple theorems. So one is theorem number 1. Fx to the power n times f dash x dx type integral. So this is general one. We have function, it has power and its derivative has multiplied. Here we have function, it has power and derivative of function has multiplied. Then you directly write here fx to the power n plus 1 over n plus 1 plus c, n not equal to minus 1. Like first integral, no? Like x to the power n type. But this is not x to the power n, but that is fx to the power n times f dash x. Okay? So theorem number 2, we have f dash x divided by fx dx. F dash x divided by fx dx. So here denominator function, derivative in numerator. Here denominator function, derivative in numerator. Then you write ln fx modulus plus c. So it is like 1 over x, no? 1 over x integral ln. But here we have f dash x divided by fx. Okay? Okay. See this? I'm going to do proof. So let this substitution, let fx equal t. Let t equals fx. Take this substitution. Now you differentiate. We call dt by dx f dash x. No? This is not division, but it has division property. Not for all, but we can multiply. Then dt f dash x divided by times dx. මේ විදිහට ගත්තට අවුලක් නැහැ. ඒක division එකක් නෙවෙයි. But you can take because limit in limit delta x goes 0, fx plus delta x minus fx divided by delta x. That is we call f dash x. Then you multiply. Then first one, take left hand side, f dash fx to the power n times f dash x dx. Fx equal t to the power n f dash x dx dt. Then x to the power n type dx type integral. කලින් ගත්ත මුල් එකම තමයි. Then t to the power n plus 1 over n plus 1. T to the power n plus 1 over n plus 1 plus c. Now replace t by fx. That's why I told you fx to the power n plus 1 divided by n plus 1 plus c. Then second one proof, you take left hand side, f dash x divided by fx dx. Then f dash x dx, it is dt. 1 over fx, that is t. Then 1 over t integral ln t plus c. Then that is ln fx modulus plus c. Okay, that's how we do. Make again up special like mas balam. Okay, right then. Okay, now let's do few examples. Let's do few examples. මේකෙන් අපිට සෑහෙන ගොඩකට යන්න පුළුවන්. අපි දන්නේ නැති ගොඩක් ෆන්ක්ෂන්ස් එකක් දැනගන්න පුළුවන් මේකෙන්. Identify the type. Fx to the power n times f dash x dx integral. F dash x divided by fx dx type integral. Okay, now see these examples. Okay, see this. Here the theorem f dash x divided by fx dx equal ln fx modulus plus c. Okay, so we can apply this theorem to integrate tan, cot, sec, cosec. Initially I haven't given that. Now see tan x dx. You write tan x sin x over cos x dx. We know cos derivative minus sin. Cos derivative minus sin. Then you write this way, cos x, you put minus sin x. To remove this minus, put the minus outside. That's it. Minus minus plus sin over cos tan. Then denominator derivative in numerator now. Then f dash x over fx dx. We say ln fx, denominator is the function. Then ln cos x plus c. Then you know how to integrate tan now. Okay. Then there's properties. Usually sin like cos, tan like cot, cosec like sec. Then if you know how to integrate tan, then similar pattern you can integrate cot. Okay, similar pattern you can integrate cot. See, cot x dx integral. Cos x over sin x. Now check. Sin derivative cos, we have it directly. You put ln sin x plus c. Okay, now you know how to integrate cot. අර කලින් ෆීල්ඩ් වෙලා තිබුණ දැන් නැති ෆන්ක්ෂන්ස් ටික දැන් එනවා ටික ටික. Then let's see sec. Sec x. Here this is somewhat special. You can't see that one directly. See the procedure. Here sec x, you multiply by sec x plus tan x. Both upstairs and downstairs. Sec x plus tan x, like this. No issue, no? We multiply both upstairs downstairs by sec x plus tan x. Now let's see what will happen. Sec x plus tan x. So when you expand, you get sec x, you get sec x plus tan x. No? Sec x into tan x. Now check this. So you can cancel sec plus tan, the result sec. Then here the result sec. Now if you consider derivative of denominator, sec derivative sec plus tan. Tan derivative sec quad. Then denominator derivative in numerator. Then you write directly ln. ln sec x plus tan x modulus plus c. Then similarly, cosec x dx, you can do same, similar pattern. Here you multiply by cosec plus cot, both upstairs downstairs. Cosec plus cot. Now check derivative. Cosec derivative minus cosec cot. But here we have plus, no? But anyway, write it. Cosec x, cot x. Cot derivative minus cosec cot. But we have cosec cot. But you put minus, minus. To remove that minus, you put minus outside. Now minus minus you can cancel. Cosec derivative minus cosec cot. Cot derivative minus cosec cot. ये minus cosec cot है. Now denominator derivative in numerator. ln cosec x plus cot x modulus plus c. That's how we take it. Okay. Now you directly remember cosec, sec, tan, cot integers. කලින් මම කිව්වේ නෑ මතක තියාගන්න කියලා. මොකද මේ process එක කියන්න ඕනේ ඉන්න. හැබැයි දැන් මේක ඔයාලා direct දැක්කොත් apply කරන්න මතක තියාගන්න. මේක ගන්නත් මතක තියාගන්න. කලින් ඒවා direct apply කරාගේ. මේකත් පුළුවන් හැබැයි ගන්න මතක තියෙන්නත් ඕනේ. Okay. Write those applications.